All right. For number 6, if you missed it, and even Lexi, you could do this right now just so you can learn the stuff that you missed. If you missed this one, we are multiplying in this problem. And when we multiply, these are test corrections, Jasmine. When we multiply, the first thing we have to do is factor. So we are going to factor anything that can be factored. Can I factor z squared? No, the best I could really do is write it as z times z. So if you want to do that, you can, because z times z is z squared. But other than that, there's not much I can do with that. What about the z plus 1? Can I factor that?
No.
Can't factor the z plus 1 because there's no squared and there's no GCF. What about the z squared plus 3z plus 2? Can I factor that stuff I just circled in pink?
Yeah.
What do I get when I do that?
2 and 1.
Good. Z plus 1 and z plus 2. And in the denominator. Good job, Danya. Z parentheses z plus 3. Guys, let's focus. Stop talking. All right. So we were able to factor the numerator and denominator of this. Now we need to see if there are any multiples on top that match the ones on the bottom. Because if there are, we can simplify. In multiplication problems, we're allowed to simplify factors. What do you see, Colin?
Z and z plus 1.
Z, you mean, the z's we can get rid of and the z plus 1s we can get rid of. Does anybody see anything else besides what Colin already identified? All right, good job, Colin. You got everything everybody could find. Okay, so now, sorry, Lexi, go ahead.
It's probably gonna not make any sense, but why can't you just cancel out
Diego. Shh. Sorry.
the z squared plus 3z since it's on the top and the bottom? Why can't you just
Okay.
take it out?
These are terms. So these two parts here are terms. We can't cancel out things that are added together. We can only cancel out things that are multiplied together.
Okay, that makes sense.
So that's where that came from. Great question. All right, so the leftovers that we have for the whole thing are the z from right here and the z plus 2 from right here. And from the denominator, we still have the z plus 3. So we've got z times z plus 2 divided by z plus 3. And we are also supposed to find the restrictions. Remember, we have restrictions at any value for z that's going to make us divide by 0. And those come from the original problem. So up here, this can't equal 0 and neither can this. So to figure out what would make z plus 1 equal 0, I say z plus 1 cannot equal 0, and I solve that little problem. And I get z cannot equal negative 1. So that's one restriction. Over here, I have z squared plus 3z. Remember, we factored that to equal this. So I can't let z equal 0 because that's from right here. That can't equal 0. And I can't let z plus 3 equal 0 either. So neither of those are allowed to equal 0 because if they do, I'm going to be dividing by a 0, and that is illegal. So here's another restriction that I don't need to solve. And over here to solve it, I just subtract 3 from both sides, so I get z cannot equal negative 3. So I have 1, 2, 3 restrictions, and then my actual solution is right here. Colin? Yes. The denominators before you start canceling stuff out. All right? Great question. So restrictions come from denominators only. Let's take a look at number 7. In number 7, we're supposed to be dividing. Division is like multiplication, except what do we have to do before we multiply? We flip the second fraction. Good job, Diego. All right. So we factor first, and then we flip the second fraction so that we can change it to a multiplication problem. Can I factor c plus 1 with a GCF or a couple of parentheses?
No.
Nope. So just write c plus 1 down. Can I factor a c minus 5?
No.
No GCF, no parentheses that I could use. Over here, can I be able to have a common denominator? So, what do I have in this one that this one doesn't have in the denominator? I don't have a b plus 2 over here, but I had two things over here. So I've got to take this b plus 2 and multiply it right here. But I can't just multiply to the bottom of a fraction. I also need to multiply on the top. So in order to get common denominators, this guy's got to be over here. So I'm going to multiply times b plus 2 on the bottom and b plus 2 on the top. And the reason I'm allowed to do that is because basically I'm just multiplying by 1. It's a weird looking one, b plus 2 divided by b plus 2, but when you divide something by itself, it doesn't, you get a 1. So now I have all of this, the b minus 1 and the b plus 2, in the denominator. And that's going to stay in the denominator, b plus 2 and b minus 1. We don't change the denominator once we get it to be the same thing. What we do change is the numerator. And to change the numerator, we simplify. Now, we factored this, but what does it equal when we multiply it back together? What? Whoops, sorry. Where did that come from? What does this yellow stuff equal when we multiply it all back together? Because that's what we have to do. We'd have a b squared and a minus 8, but don't forget about the negative 4b and the positive 2b. Multiply the insides and the outsides. Do you guys remember where this came from?
Yeah.
It's still in yellow at the top, isn't it? So if we remember that we did that before, we can save ourselves the trouble of having to do it again. This is b squared minus 2b minus 8. Now over here, I had a negative 6, and it's multiplied times the b plus 2. So I'm going to have a negative 6b, and negative 6 times 2 is minus 12. That's one way to do it. A lot of people miss this problem because they forgot that that minus sign went with the 12 as well. They put the minus sign with the 6b, but not with the 12. And so that caused a little bit of trouble. Brianna, do you have a question? You good? Okay. All right, so I haven't finished this problem yet. Does anybody see anything else that I can do? Like terms. Does the b squared have any like terms? No. What about the negative 2b? And the negative 6b? And when I put those together, I'm going to get negative 8. Let me see if I can do that. B squared minus 8b. And what's left here? The negative 8 and the negative 12. Put those together and I get negative 20. Okay. So b plus 2 and b minus 1 are still on the bottom. We haven't done anything to them since we got a common denominator. Okay. Now I'm looking at the answer choices, and I don't see this in my answer choices. So what could I maybe do so that I could get one of the answer choices that I see on my test? Simplify what?
Like the bottom.
Yeah, look at that top. In that top, I have a b squared minus 8b plus 20. Or minus 20, sorry. And I can factor it because what can I multiply to give myself a negative 20 that also has to give myself a negative 8? 10 and 2. One of them's got to be negative, though. Which one? The 10, because we want the 8 to be negative. So we have a b minus 10 and a b plus 2 divided by the denominator that has been the same since the second step we did. And now we can simplify exactly. B plus 2 divided by b plus 2 leaves us with a 1 there. And my final answer is going to be b minus 10 over b minus 1. Okay?
That's a long problem.
That was a long problem, definitely. And there were a lot of tricky things in there. But now that you've seen how to do it, hopefully the next time you see one like that, you'll be good to go. Now, like I told Danya a second ago, I am recording this as I speak, So if you need to watch these again before our retest, which I did get permission to do on Monday during Smart Lunch, not next Monday, not after this weekend, but the one after that. So you have about a week and a half still to study this if you need to. All right, we're still going. Number 9. This one's kind of like the last one. We're adding, not multiplying or dividing. Can I factor a 7? No. Can I factor an a plus 8? No. Can I factor this 7? No. Can I factor the a squared minus 64? Yes. There's no GCF. Plus 8. Plus 8 minus 8. Plus 8 minus 8. Okay. All right. So just like the last one we did, if we are adding or subtracting, we have to have common denominators, and those do not have the same thing in the denominator. But what can I do so that they will have the same thing in the denominator? Good job, Naya. I heard you loud and clear. A minus 8. I'm going to multiply by that in the numerator and the denominator only on this fraction. Because I needed my 2 terms here to have the same denominator, and they didn't before. So now I've made that happen. And so my denominator is going to stay the same for the rest of the problem. I'm not going to change it. I'm not going to multiply it. I might simplify it if I can find something to simplify, but other than that, we're done with that. All right, in the numerator, we got to take everything that's up here and put it all together into one thing. What can I do with the 7, Diego? Multiply it by the a and the 8. So I get 7a minus 56 plus the pink 7 that's sitting over there. I put those together. You said 49? Okay. So I get 7a minus 49 divided by a minus 8 and a plus 8.
Where'd you get? Oh, never mind.
You sure?
Yeah.
Okay. All right. So I'm looking at the answers right now, and I do see that answer sitting right there on my paper. Awesome. Okay, so to add or subtract, we have to have like denominators. Once we have like denominators, we keep them until the very end when we can simplify maybe. Last one. Another addition problem. So again, we have to have like denominators and we have to factor. Now, here's a sneaky tip. Do you guys remember a little while ago when I factored this yellow stuff up top and then I had to change it back to the way it was to begin with anyways? All right, so really, factoring the top is going to be a waste of our time because I'm going to have to multiply it back together anyways. So you can factor it if you'd like, but that's not a requirement if you don't want to. I'm not going to do that right now, just to save us some time. I'm just going to write that guy down again. But I am going to factor the denominators so I can find a common denominator. In the denominator, what multiplies to give me a negative 30 and adds to give me a positive 1? 6 and negative 5. Okay, over here, I don't think I can do anything with the 8 and the w minus 5, so I'm not going to even bother. What do I need to do next? Good. 5 minus, or w minus 5, and I need a w plus 6. Gotta have like denominators when I'm adding or subtracting. All right, so now they're matching. I'm going to keep my denominators the same for the rest of the problem unless there's something I can simplify maybe. But in the numerator, I've got to put everything together. Because I didn't factor the yellow part up there, I'm just going to combine it with my orange-blue thing over here and see what I get. Now, just because I'm almost out of room, what am I going to get when I multiply all of this together? 8w plus 48. Good job. 8w plus 48. And now I need to combine some like terms. So I've already simplified this. That's right above it. I see that w squared. Does it have any like terms? Nope. So w squared. What about the 2w? with the 8W, so that gives me 10 of them, right? And then the negative 24 with the positive 48 giving me 24. All right, looking at my answer sheet, am I done? Dang it. That's not on there. I got to factor it. So now I ask myself, what multiplies to give me a 24 but adds to give me a 10? A 6 and a 4, both positive? All right, W plus 6, W plus 4, divided by W minus 5, W plus 6, simplify. So we have a W plus 4 divided by a W minus 5. Done.